Okay, this lesson is Unit 8, Lesson 2. This is about similar polygons. This is a very powerful tool in geometry because it allows you to solve for different things that you're missing just based on the fact that you know they're similar to another shape. Okay, similar polygons. These are polygons that have the same shapes but different sizes. For polygons to be similar, these two things that are following are both required. The corresponding angles of similar polygons have to be congruent. The corresponding sides of similar polygons are proportional. So this means we're going to use proportions to do some of the solutions here. The mathematical symbol that indicates similarity between polygons is the tilde. Okay? So if you see the name of a polygon with a tilde between it and another polygon, that means that they are the same shape, but it means that they do not necessarily have the same size. Okay? Example 1. What angles must be congruent and what examples of the ratios of the sides that must be all the same? Or in other words, proportional. Okay? So here's what the thing is. If we got these two quadrilaterals, notice that the corresponding angles are all marked congruent. So angle B is congruent to angle F, angle C and angle G are congruent, angle H and angle D are congruent, and angle E and angle A are congruent. We know that from the markings they have here. So the only thing that must be sure of is that we know that those corresponding angles have to be congruent. So we note that by saying angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. Okay, the things that must all be the same in the proportions is this. 11 has to, since 11 and 22 correspond, the ratio of 11 to 22 has to be the same as 9 to 18, 3 to 6, and 14 to 28. Okay, scale factor. The ratio of the lengths of the corresponding sides. This just means that if you find the ratio of the two pairs of corresponding sides, that is the ratio of the polygon itself to the other one. With similar polygons, the scale factor is consistently the same regardless of which ratio of corresponding sides is used. Okay. Even if only one ratio is inconsistent between the two polygons, they are not similar. So it just takes one of them not being the same for it to make them not similar. Okay, example 2, using the similar polygons of example 1, determine the scale factor of quadrilateral EFGH to quadrilateral ABCD. Show that the scale factor is the same regardless of which ratio is used. Please note, the one that they list first has to be the top one in the ratio. Okay, so EFGH is this one on the right. So we need to take a corresponding side from it and relate it to the corresponding side to the one on the left. Okay, so the scale factor is equal to 22 to 11, which is equal to 2. The scale factor of the next pair of corresponding sides is 18 to 9, which is 2. The scale factor of the third pair of corresponding sides is 6 to 3, which is 2. And the scale factor of the last pair of sides is 28 to 14, which is also 2. So therefore the scale factor is the same for all four pairs of corresponding sides. Okay, using the similar polygons from example 1, they want you to determine the scale factor of quadrilateral ABCD to quadrilateral EFGH. We already know they're similar, but since they changed it this time, the top value needs to be the one from the one on the left, and the bottom value needs to be the one from the one on the right. So we redo our work. So the scale factor is 11 to 22 equals 1/2. Okay. Notice that is the reciprocal of the other one. Okay. Example 4, they want us to determine if these two triangles are similar. So they gave us two triangles. One's a 3, 4, 5 triangle. So we know that's already a right triangle. The other one's the right triangle, but we need to know if it's in proportionality to the other one. So what we do is we simply go with this. And since we have two of the angles marked the same, that means that all three angles have to be the same between them. Okay, so 3 to 9 are the corresponding side, one set of corresponding sides, and we need to know if that's equal to 4 to 12 and 5 to 15. Okay, so we reduce all these fractions. We get 1/3 is equal to 1/3 is equal to 1/3. So that checks out, and that means that these two triangles are similar. The small one is 1/3 the size of the large one. Also note that the corresponding angles are marked congruent. That was very important before you can determine whether it's similar. So yes, they are similar. Triangle ABC is similar to triangle DEF. Find the scale factor of triangle DEF to triangle ABC and determine what x is. Okay, so here's what we got. We know that all three angles are the same because two of them are marked congruent, and in a triangle, if you know two of them, you also know the third one, because that determines what it has to be, because they consistently have to add up to 180. So what we need to do at this point is establish the relationship between the sides. So A to B, AB, it needs to correspond to DE, so that would be 3 to 2. And actually they want to go the other way, so it would be 2 to 3. And so EF is 6, BC is 9, so that one would also be 2 to 3. So the scale factor of DEF to ABC is 6 to 9, which is 2 to 3 that we just said. Okay, so we set up a proportion to say 11 over x is equal to 3 over 2. So 3x is equal to 22. Okay, so x is equal to 22 divided by 3. That would be the length of DF. In discussions of similar polygons, the term included angle and included side are often used. Okay, so you need to know what those look like. Here's one quadrilateral, ABCD, and so example 6, they want to know which angle is included besides or between side AB and side BC in the drawing above. Okay, so if you look at this, what we have is the angle that's between those two is angle B. Okay, which side is included between angle B and angle C in the drawing? Okay, once again we have the same drawing. So we have angle A, or angle B and angle C. So the side that's included between them is simply segment BC. Okay, example 8. If the lengths of the sides of a triangle are in the ratio of 4 to 5 to 6 and its perimeter is 150 feet, what is the length of the longest side? Anytime that you have this, you take the extended ratio 4 to 5 to 6, put an X on each one of those numbers, and since we know that those are the sides and we know what the perimeter adds up to, we can simply say 4x plus 5x plus 6x equals 150. Combine the x's, gives us 15x equals 150. Divide both sides by 15, gives us x is equal to 10. So the longest side is going to be the one that's represented by 6x, so 6 times 10 equals 60 feet. Okay, that concludes this lesson. Be sure once again that if you have questions or you're confused about anything, that you record your thoughts on a piece of paper so you can bring it with you tomorrow and ask the questions before we start the work. We will see you tomorrow. You have a good rest of the evening. Thank you. Good night.